Welcome to Spring LIB.
Hello and welcome to this video solution of numeric. So here we are given that there is a block A, right? That is resting on a pan B, right? This is a pan B and which is connected to a spring, right? There is the spring constant is K, and that you have to determine the distance D. The pan should be pushed down from the equilibrium position, then released from rest, so that the separation of the block will take place from the surface of the pan at the instant when the spring become unstretched, right? So this is pretty simple. So first of all, you need to have the forces that are acting on the system. First of all, if you consider the combined system, here you have the B and here you have the A, right? So the weight W acting downwards, right? The spring force Fs is acting upwards and the overall force F will be directed upwards itself, right? So that means what you can do is M A plus mb is the total mass times the acceleration, which is this net force, that will be equal to the spring force Fs applied by the spring compression minus the weight W, right? And this is Ma plus mb times A, that is equal to the spring force will be K times y. Let's say this is the equilibrium length plus y is the excess length, right? Y. And this minus here you will be having Ma plus Mb times G is the weight, right? And from the other section of only the mass A, right? So here what happens is the weight Mag is acting down, the normal reaction will be upwards, and here you have got on the upper side Maa is the acceleration, right? So let's say this is equation 1, and from the other block you have got Ma times A, that is equal to this normal reaction minus Mag, right? Or the normal reaction N will be equal to uh, Ma A plus Mag, right? This is equation 2, let's say. Or rather, here from here you can get the value of acceleration. Sorry, here you can put acceleration, that's better, equal to n minus Mag by Ma, right? So let's say this is equation 2, and you can plug it in equation 1 itself, right? So here you have got Ma plus Mb, acceleration will be n minus Mag by Ma, right? That is equal to K times of y equilibrium plus y minus here you have got Ma plus Mb times G, right? And here you have got y to be equal to minus D, and the normal reaction N to be equal to 0, right? Y equilibrium is pretty simple. Y equilibrium will be equal to the spring force over the Y equilibrium is the weight over Ma plus Mg times G by K, right? Ky equilibrium will be equal to this value. Now you have to plug in all these values here. So here you have got Ma plus Mb. Here you have got normal reaction to be 0, and this will be a minus G here, that is equal to K times minus D plus here you have got Ma plus Mg by K times of G, and finally here you have got minus Ma plus Mb G, right? So this can be cancelled. So this D will be equal to MA plus MB by G or times G over K, right? So this is the value of D you will be having. I hope this is clear to you and have a very good rest of the day. Thank you.